Okay, so we were doing the first example of Newton's third law without friction, just before that last video ran out. And we were on part D, the force of tension between the car and the first trailer. And so we had some of the forces on this trailer would be equal to the force the car was putting on the first trailer going forward, and the force that the second trailer was putting on the first one going backward. So Fc of the car on one minus the force of the second one on one. Bring the force of the second one over, becomes plus. We found it up above. Can't believe that someone wrote kilograms there. So this would be plus 4,000 newtons. 3,000 plus 4,000, so this should be 7,000 newtons. Okay? Now, you can check your work, okay, and the check would be to look at the car. So on the car, because we've looked at the two trailers, on the car whose mass was 1,000 kilograms, we found that there was a force of 900 newtons going forward and a force of 700 newtons going backward. So if we did the sum of the forces on the car should be equal to the mass of the car times A, for F minus the force that the trailer's putting on the car will be equal to M of the car A. So then fill your values in. 9,000 newtons minus 7,000 newtons is equal to 1,000 kilograms times 2 meters per second squared. Lo and behold, you get 2,000 newtons equals 2,000 newtons, which means you must not have screwed up. Okay, so this is without friction. If you flip the page over, there's a second one without friction. And I would like to suggest that you pause me right now, try this second one, and then turn this video back on. Okay, and go. All right, so assuming that you paused me, now it's back on, so let's see how you did. So it's a truck pulling two trailers. So there are my trailers. Here's my truck. The truck is 6,450 kilograms. The first trailer is this guy, and it's 20,000 kilograms, and the second one is 15,000 kilograms. Okay, and it says you can ignore friction. It starts from rest, it tells us VI is 0, and it accelerates to a speed of 26 kilometers per hour. Why would I do that? That is not going to be a pretty number. In 15 seconds. Delta T is 15 seconds. So it's almost the same as the last one. 26 kilometers per hour, 7.2 repeating meters per second. A is equal to VF minus VI over delta T. And this goes to 0, so 7.2 meters per second divided by 15 seconds gives you an A of 0.481, which repeats meters per second squared. And it does repeat if you don't round your 0.2. What is the force that the truck must generate to accelerate the entire vehicle, the entire system? So it's telling you, look at the system. Okay, so on the system, we have 6,450 kilograms plus 15,000 kilograms plus 20,000 kilograms. That's the whole system. There's no friction, so the only force will be the F pulling forward. Do sum of the forces is equal to M total A, so it'll be F is equal to 41,450, I think 41,450. And the A is 0.481 repeating, which you should keep in your calculator so you don't end up rounding it. And when you do this, you get 19,957.407, and the 407 repeats. Okay, so the numbers aren't pretty, but there they are. I really need to change the acceleration and it'll be better, or this 26. Part B wants to know what force must each trailer hitch withstand. So now you're looking for the internal forces. So to find the internal forces between the trailers, you need to look at the individual parts. So always start on the back one. So on number 2. So this is 15,000 kilograms with no friction. We have F of 1 on 2 pulling forward. We do the sum of the forces will equal M2 times A. So it'll just be F12 is equal to M2A. M2 is 15,000 kilograms, and A was that 0.481 repeating again, meters per second squared. And again, if you do not round, you get 7,222.2 repeating newtons. Okay, so that's on the first hitch. That's this one. Now we want to find this hitch, so now we can look at number 1. So you always start on the back one, because if you started on the middle one, you wouldn't know either of these two forces. So start on the back one, it only has this force of tension. Middle one has both. Okay, so on number 1, which is 20,000 kilograms. So pulling forward is the force of the truck on number 1, and pulling backward is the force of 2 on number 1, which we just found. So when we do sum of the forces is equal to M1A, it'll be F of the truck on 1 minus F12 or 21, it's the same thing, will equal M1A. So you're looking for the truck on number 1, it'll be M1A plus F12. So M1 was 20,000 kilograms, A was 0.481 meters per second squared, and that's repeating, plus this 7,222.2 repeating. And if you manage to keep all your repeatings, you get 16,851.851, which also repeats. This one will be bigger, and it should be, because, right, the force in this hitch has to be bigger than the back one, because this hitch is really pulling both of them. Just the same as back here, the hitch between the car and the first trailer was 7,000 newtons. The second hitch was only 4,000 newtons. So the first connector is always going to be bigger, the first connector in the row. If you want to check, then you look at the truck. So looking at the truck, it was 6,450 kilograms. Pulling forward is this force of 19,9157. Pulling back is the truck in number 1. So sum of the forces will equal mass of the truck times A. So it'll be F minus F1T will equal mass of the truck. I'm writing TR there so you don't think it's total. So 19,957.407 newtons repeating minus 16,851.851 repeating should equal, going to run out of room, 6,450 kilograms times 0.481 repeating. If you can hold on to all of your repeatings, you end up on each side to get 3105.5 repeating and 3105.5 repeating. If you can't hold all the repeatings there, it'll be close probably. Okay, so that's without friction, but we know that really there's friction. So we need to spice it up a little and look at example 3. Example 3 is a person pulling 2 toboggans. So here's toboggan number 1, here's toboggan number 2. Okay, actually I'm going to make this one number 1 because I had all the other ones moving forward. Okay, so this guy is 25 kilograms and this one is 30 kilograms, and it says you're pulling. Okay, a person pulls 2 toboggans by applying a force of 180 newtons. We're going to run out of time here.